I'm getting more and more into a habit to have enough daylight. It's obvious to you if you've been following my lectures regularly that the visibility of the board is higher if I'm filming in daylight. So I try to have the board written up before 4 p.m. or earlier, so that I still have enough daylight to film, and that I can watch YouTube videos and stuff, science documentaries and whatnot, when I relax at night, because then the internet speed is faster. Alright, so this board, what are the themes? There's advice on how to go about designing CFGs, context-free grammars. Designing, of course, is harder than analysing usually. So there's like 4 tips given for that. And then we get into two new topics after that on the board. One is ambiguity. What that means is that you can derive the same string and the 2 derivations have 2 different parse trees. Okay, so that phenomenon is called ambiguity. So you can have ambiguous languages that allow this. And towards the end, certainly in the last session, there'll be something called Chomsky normal form, which is a kind of simplified way to specify a CFG. So it's a way of writing a context-free grammar in a very simple form. In fact, so simple that it's very useful for automating, having a computer analyze the grammar for you by insisting that grammar is written in something called Chomsky normal form. That's the same Chomsky is talking about in a couple of sessions about who's famous for being the guru of modern linguistics. He just revolutionized the subject, and being a very severe critic of the abuses of the American government, abusing its power, its world dominant power. Right, so start with the idea of designing CFGs, context-free grammars. In general, it's thought, well, Sipser claims, it's thought to be harder, in fact, in general, to design a CFG, to design a grammar, than it is actually to find a machine to recognize a language. So you're recognizing language, that's what a DFA does, deterministic finite automaton. And the reason for that is that we're probably more accustomed to designing machines for a given task than trying to describe a language with a grammar. We're not used to this in general. It's not part of the daily routine, let's say, not part of normal life experience. Okay, so what happens now? Let's see, for two sessions, pretty much, we discuss some techniques, some tips, guidelines, if you like, on how that are helpful in designing CFGs, context-free grammars, where you actually get to create them. And let's see, I haven't checked. So we're into chapter 2 now. So how many questions on context-free languages, CFLs, are there? 45. So proportionally, actually more. The previous chapter was 30 pages and had 65 questions. This chapter has 30 pages and 45 questions. 1.5 questions per page. Previous one was 65 divided by 50. Yeah, proportionally more. Okay. So there'll be a lot of questions there. I assume, I haven't checked in detail yet, but I assume there'll be a lot of questions on asking you to create, to design grammars, context-free grammars, for a given language. So you get a lot of practice. All right. So here's some four tips, four guidelines, four techniques that you can use. We'll start on the first one. Often languages they have parts sometimes. In the sense that a language might be the union of say, two smaller languages. I'll give you a concrete example. Here's a language. Well, here's one language, and here's another language, with a union between the two. So now remember, a language is just a set of strings, right? A set. So you have one language, another language. That means you have two sets, okay? And a union is defined on two sets. So you just combine the elements of the two sets into one big set, right? So that's an example of the union of two languages. Okay. Well, if you have that kind of thing, where you have a larger language that really is comprised of two parts, like the union of two smaller languages, well, it might be a good idea to find the grammar separately. So the grammar for this one and the grammar for that one, and then I'll explain in a minute how to do that, and then to combine the two grammars into a larger grammar, and then the larger grammar would generate this larger language. Okay, so it seems fairly reasonable, right? So I'll say that in different words. You split up your larger language if it's of the form a union between two smaller languages. You find the CFG, you find the grammar for the two parts. So it'd be like CFG 1 for language 1 and CFG 2 for language 2, and then you merge those two grammars. Now, how do you do that? So you merge the two CFGs. Well, you add a rule. You have a new, so we're talking about unioning just two languages, right? So this language will have its start variable, call it S1, and this second part, it's a language. It has its start variable, call it S2. Okay. Now, in general, if you have a union of say K languages, K parts, you'll have K start variables. Okay, S1, S2, ... sk. So to merge them, what you do is you add another rule. You have a new state, the start state of the whole language, the language, the larger language with all its parts. Okay, let its start variable be S, and so you add a new rule that's of this form. So S can, you can replace, substitute S for S1 or S2, or SK. Right? So you add that rule. What else? Well, that's effectively it. Right? So well, of course, you have to in the rule R, the rule set for your whole language, you'll have to add all the grammars, in other words the rules. You'll have to add R1 and R2, ... RK. You have to add all those rules into one big